Hello guys, welcome back, and today we are going to be discussing two very important topics related to vehicle dynamics and in particular suspension design and handling, which is known as understeer and oversteer. So basically what these two terms mean, understeer and oversteer are basically vehicle tendencies on how they maneuver through a curve. So basically understeer means that we have a turn of radius r and the vehicle is supposed to go like this, but has a tendency to rather go straight and not follow the maneuvering turn. Oversteer on the other hand means that whenever we have a turning radius of r, the vehicle is supposed to go like this, but with a small steering input, vehicle tends to turn more than the required turning radius, and then the vehicle is said to have the tendency of oversteering. So now we'll look at this formula for the angle of turn on the front wheels for a car. I've got this formula from Fundamentals of Vehicle Dynamics book by Thomas D. Gillespie. However, this entire formula, we are going to be focusing on this particular part of this formula known as understeer gradient. Now if you look closely at this formula, we have multiple values. Wf, which stands for the weight on the front axle, V is for the velocity of the car, C alpha F and C alpha are basically cornering stiffness values for front and the rear tires. G is the gravitational constant, which is 9.8 meter per second square or 32.2 feet per second square, and R is the radius of the turn that we are maneuvering through. So if you if in this particular formula, the if the value is overall value of this formula is positive, then the vehicle is tend to having a understeering tendency. If the value of this formula is understeer gradient is 0, then the vehicle is said to have a neutral steer. That is, the required amount of steering input will make the vehicle maneuver through that particular radius of the turn. And if the overall value is negative, then the vehicle is said to have oversteering tendency. That vehicle will have a tendency to turn more than the required turning radius. Now look at this formula and let's try to make sense of all these values in here. So we have V, which is the velocity of the vehicle, which will be the same in both the parts. Then you have G, gravitational constant, which will be the same, and R, the radius of the turn, which will be the same as well. Cornering stiffness, which lateral force over the slip angle, which depends on the type of tires which are used, if the tires are new or worn out. So this value can vary, and this value, the weight on the front and the rear axle, will be differing depending on the type of vehicle we have. So for now, let's consider the cornering stiffness is the same for both the front and the rear wheels. So in that case, V, C alpha, G and R will be the constant values. Now the only thing differing in these two parts of the formulas is Wf and Wr. So if you think about a regular car that we drive every day, which has a weight which has engine placed on the front axle, that means the weight on the front axle will be higher than the weight on the rear axle. That means this value will be higher than this value, thereby making the understeer gradient a positive value, and that means the vehicle will have a tendency to understeer through a curve. Now if you try to make sense of this equation over here, think about it as if you remember the laws of inertia. So a particular object with mass will have a tendency to resist the change in its state. If it's in motion, it will try to remain in motion. If it's in rest, it will try to remain in rest. Now think about it from a vehicle perspective. You have your regular car which has a engine placed on the front, and if you are maneuvering through a turn, that weight on the front axle will have a tendency to keep on going straight, and that's why you have to overcompensate to make that weight move in your required direction or to make that particular turn. So that kind of makes sense over here. If the weight on the front axle is more, that will also affect the turning of the vehicle, like the weight and that inertia because of the weight of the engine placed on the front will resist the turning in their movement, because the vehicle is moving in the straight direction and then it will resist the turning. So this, now it kind of makes sense. Similarly, if we think of a car which has engine placed on the rear axle or a mid-engine car, then the weight on the rear axle will be higher than the weight on the front axle, and this value will be higher overall than this value, and the value will be negative, and the vehicle will have a oversteering tendency. Again, the same law of inertia kicks in. Like if we have weight on the rear axle, once we get it turning, the weight will have a tendency to keep on going on that turning radius rather than keep on going straight after some time with after when we have maneuvered through that particular turning radius. So that again makes sense, like why higher weight on the rear axle will have a tendency to oversteer. Now consider that you have your regular front engine car, weight on the front axle is higher than the weight on the rear axle, or but in that case we have worn out tires on the rear. Like we have the same tires on the front and the back, same company, same dimensions, everything, but on the rear the tread of the tires is worn out, so the rubber is not laying as much on the road, so the rear tires are not that grippy. That means that whenever the car is turning, not that much slip angle will be generated because there is not enough adhesion between the rubber and the road to make that turn in the tire. Less slip angle in the tire on the rear means less lateral force will be generated. And when we look at the formula over here, less slip angle means less lateral force is generated. That means coefficient of cornering stiffness will be lower. If the cornering stiffness will be lower, if this value goes down for the rear tires, because the rear tires are worn out as we are assuming right now, then this value will be overall higher and the vehicle will have a tendency to oversteer. Even though it's a front engine car, the worn out tires on the rear will give it a oversteering tendency. Now on the same front engine car, if you think about worn out tires on the front, that means again not enough rubber is laid out on the road. So not enough rubber, that means we cannot generate that much amount of slip angle because of not enough adhesion between the tire and the rubber and the road, and that means lesser lateral force is generated. Lesser lateral force means lower cornering stiffness for the front wheels. Lower cornering stiffness on the front wheels means overall higher value for the first part. That means there should be a positive value and the vehicle will have a tendency to understeer. So basically two things we have learned: more weight on whatever axle, front or rear axle, that will define the tendency of a car, because slightly because of law of inertia it will have a tendency to oversteer or understeer depending where is the weight on the vehicle, front axle or the rear axle, and also how much grip we are having on the front and the rear axle. If on the like grip, I mean like how much tire we can lay on the road. If we have less tire laying on the road on the front, that means the vehicle will have a tendency to understeer. If we have more tire less tire on the rear of the vehicle, then it will have a tendency to oversteer. Obviously it kind of compensate depending on if it's front engine or rear engine car, but this is how we have to make adjustments depending on what is the design of the vehicle. I hope all these values are clear, and before we close the video, always remember cornering stiffness is only valid for the linear range. So whenever we have a graph for lateral force versus slip angle, the graph kind of goes like this. This formula, cornering stiffness, is only valid for lower slip angles where the relationship between lateral force and slip angle is linear. For extrapolating the values for the entire graphs, we have different tire models, in particular Pajeka model that I use for my calculation, which extrapolates this value, which correlates slip angle and lateral force with each other, and which gives you this kind of a graph, also known as magic formula. Over here, cornering stiffness is only valid for low value slip angles. I hope everything is clear and well understood for you guys. In case you have any questions, let me know in the comments, and I'll see you all in the next video.